Hello everyone, welcome to my new video. And in this video, it talks about properties of limits. And I will discuss and also give an example about the different properties of limits. So let's proceed. Properties of limits. If limit n as n approaches to a equals a, limit bn where n approaches to infinity equals b, and c is a constant. And now, the first properties of limits is limit c where n approaches to infinity equals c. So, we know that c is a constant. And the limit of a constant is itself. For an example number 1. Limit 4 as n approaches to infinity equals to 4. Because because the limit of a constant is itself. Limit 4 where n approaches to infinity is equals to 4. So the answer is 4. Number 2. Limit 5.14 as n approaches to 2 equals 5.14. So that is our answer. Number 3. Limit 560 where n approaches to c is 560. So that is our answer. Next. We are now done for our first properties of limits. So let's proceed to our second property. The limit of n as n approaches to infinity is equals to infinity. And this properties is more like substituting the value of n. So let's take for an example. Example number 1. Limit n where n approaches to infinity. So let's just substitute the value of n, which is infinity. So the answer is infinity. Oh, wait. Infinity. So that is our answer for number 1. Number 2. Limit 2n where n approaches to 2. Let's substitute the value of n, which is 2. So 2 times 2 equals 4. So the answer is 4. Number 3. Limit 20n as n approaches to negative 2. So 20, substitute the value of n, which is negative 2. The answer is negative 40. So that is our answer. And let's proceed to our third properties. This property is also called the constant multiple theorem. Limit c times an as n approaches to infinity is equals to c limit an where n approaches to infinity equals c times an. So let's take for an example. Limit 2 times 2n. Let's all we need to do is to substitute the value of n. 2 times 2, substitute the value of n, which is 2. So 2 times 2 equals to 4 times 2 equals to 8. So 8 is the answer. So number 2 example. Limit 4 times n as n approaches to negative 2. So 4 times substitute the value of n, which is negative 2. The answer is negative 8. So that is our answer. Now, we're done to our third property. Let's proceed to our fourth properties, which is also called the addition theorem. So when we say addition theorem, it is the limit of sum of the function is equal to the sum of the limit of the individual function. So the general equation is limit an plus bn as n approaches to infinity equals limit an as n approaches to infinity plus limit bn as n approaches to infinity equals a plus b. For example number 1. Limit n plus 6 as n approaches to infinity, so is equals to let's distribute the limit an, which is this, is n plus our bn is 6. So limit 6, which is our limit of n is infinity because n approaches to infinity. So infinity, our limit of 6 is constant, so our limit is 6. Our limit for bn is 6. So infinity plus 6 is equals to infinity. So our answer for number 1 is positive infinity. And for our second example, limit 3n plus 1 over n as n approaches to infinity. So by distributive law, we distribute the limit, which is three over n plus 1 over n, 3n I mean. So 3n over n, we cancel the n. So the remaining is 3 plus 1 over n. So we have now, so let's distribute now the limit. Limit 3 as n approaches to infinity plus limit as n approaches to infinity 1 over n. So limit 3, the limit of 3 as n approaches to infinity is 3. We use here the property 1. And the property 2. And limit 1 over infinity is equals to 3 plus 1 over infinity is equals to 3 plus 0. So 3 plus 0 equals 3. So our answer for number 2 is 3. So we are now at our fifth property of limit. So our fifth property is also called the multiplication theorem. So when we say multiplication theorem, it is the limit of the product of the function that is equal to the product of the limit of the individual function. So we have the equation limit an times bn as n approaches to infinity equals to limit an as n approaches to infinity times limit bn as n approaches to infinity equals a times b. So, for example number 1, limit x cubed times x squared plus 3 as x approaches to 2. So, let's distribute the limit. Our limit an is limit x cubed as x approaches to 2 times our limit bn is limit x squared plus 3 as x approaches to 2. So, limit x 3. So, substitute the value of x. So, 2 cubed times 2 squared plus 3. 2 times 2 cubed is 8 times 2 times 2 equals 4 plus 3 equals 8 times 4 plus 3 equals 7. 7 times 6 is 56. So, 56 is our answer. So, let's proceed to our last property of limit, which is also called division theorem. So, when we say division theorem, it is the limit of the quotient of the function is equal to the quotient of the limit of the individual function. So, we have the equation limit an over bn as n approaches to infinity equals limit an as n approaches to infinity over limit bn as n approaches to infinity equals a over b, provided that b is not equal to 0, because if the denominator, which is b, is equal to 0, the limit does not exist. So, for example, limit x minus 3 over x squared as x approaches to 4. So, first, let's distribute the limit. Limit x as x approaches to 4 minus limit 3 as x approaches to 4. Over limit x squared as x approaches to 4. So limit x, substitute the value of x, which is 4, so we have 4. And here limit 3 is constant, so 3. Over limit x squared, so let's substitute the limit. Let's substitute the x value, which is 4. 4 squared is equals to 4 minus 3, 1 over 4 squared equals to 16. So 1 over 16 is our answer. So I think that's all for our video. So let's meet again in my next video, which is how to evaluate limits.